Default. How about now? Can you guys hear me now? Yeah. So hopefully you guys can hear me now, and everything is working out better now than it was before. So hopefully that makes things better. There is something. Okay. Good deal. All right. Well, it's not every day you have audio issues. Every time my computer reboots after doing like a Windows update or whatever, or some sort of driver. There we go. Awesome. As long as you guys can hear me. All right. Perfect. Now we're cooking with fire. So, good stuff. All right. Yep, I'm supposed to be on the Yeti mic and not on the default one. I don't know why it doesn't automatically do that, but thank you, OBS, for not choosing the right mic. Good job, guys. Anyway, so since y'all didn't hear the first 2 minutes of me talking to myself, today's discussion will be on how do you develop labs based off of the exam blueprint topics that you guys see. That is a common question that I get, and I feel like that's something that we need to dive into and take a look at and understand, because it is something that, regardless of where you're at in your technical journey, whether you're just starting off or you're more advanced and you've got no problem dealing with labs, at the end of the day, you need to be able to interpret what you're seeing in the blueprint and then be able to put that into measurable terms. I'm stealing that from Keith Barker when it comes to how do you build a lab based off of what you're seeing. So that's what we'll be talking about tonight. We'll actually log into EVNG, and we'll actually build a mini lab based off of what the exam blueprint says. So that's my goal with tonight. You may or may not have access to the same versions of operating systems that I do. If you don't, that's okay. You can, maybe your Google Foo is good and you can find it, or you have access to it through legit means and channels. But anyway, so if I have something in my topology or my lab that you don't take it as you can't lab it up. So anyway, with that being said, I'm going to go ahead and get started. For those of you that are here in the live stream and watching, if you guys have any questions at any point in time, you guys can feel free to throw it in the chat. I will be happy to answer those questions, or stuff like that. And we will definitely dive into how all that stuff works. Anyway, with that being said, let's go ahead and I'm going to open up. There we go. We'll grab this one here. Go ahead and bring this guy over so it's just another tab, and I'm going to zoom in here. Alright, so we're going to log in here. So this particular server, I am actually working on one of the things that I have to deal with a lot in my day job is Fortinet firewalls. So I am in the process of going through and learning Fortinet at a high level and working my way through Fortinet. So my goal is to build some content around that down the road. But in the short term, one of the things that we want to do is we want to take a look at what you guys are seeing in the blueprints and then convert that into network diagrams and diagram it out to a certain extent where you guys can build a lab based off the blueprint. So we're going to start off with CCNP Enterprise because that's where most people are at. If you're not on Enterprise, let's say you're working on your CCNA, or you're working towards NP security, or maybe you're working in Palo, or whatever it might be, data center, and you want to understand how would I build a VXLAN fabric versus, or mimic something that's kind of like ACI. We can do a lot of those same things. Sometimes it comes down to just the way you build out your topology, but at the end of the day, it's just a matter of interpreting what's going on. So that's what we'll do. So we have the core exam, so we'll pull that up just for the sake of having it there, and then I'll pull up a NARCI, and then we'll take a look at SD-WAN. So there's that. So hopefully within just a couple of blueprints we'll be able to figure out most of the things we want. Now I will also mention that depending on the track will kind of dictate how you should be going about your topology development inside of your whatever platform you're labbing inside of, whether it's EVE-NG, whether that's GNS3, or if you're downloading OVAs to deploy them inside of ESXi or CML. I personally, or and if you're really fortunate, you have all hardware to do this with. So regardless of what your mechanism is to lab it up, it's important to understand the specifics. So let's take a look at the Encore blueprint, and I didn't pull these up ahead of time, but I have decent high-speed internet, so I will be able to go through here, and we'll wait for this pesky little notification pop up. Thank you, Cisco, for adding just another thing for me to worry about. All right, so when we look at the blueprint, the things that you care about right now aren't necessarily architecture, but it's going to also be architecture. So that means that you'll have to understand what are the common network designs: 2-tier, 3-tier, fabric, and cloud, as well as first-hop redundancy and stable switchover. So you'll have to understand how these things come into play, but at the end of the day, these are more, there's going to be certain things that you're not going to be able to lab up. For example, virtual stack-wise is not supported on the virtual switches that I've seen. I haven't tested them out on Cat 8K yet, but most people know that all you have to do is run a couple of fiber links between a pair of switches, and then you just associate the appropriate interfaces to your Stackwise config, and Bob's your uncle at that point. And Stackwise just starts to work. So, but if you guys have specific questions on, whether it's chassis aggregation, which is what Stackwise essentially is, or VSS, virtual switching system, VPC, virtual port channel, they all basically do the same thing. They're chassis aggregation, which is different than chassis virtualization, which is VLANs and VRFs. And if you're on old school Nexus, it's VDCs. So with that being said, we'll take a look at specifically how the implementation piece comes into play. Now, if you take a look at how, like this guy says right here, layer 2, it says troubleshoot static and dynamic 802.1q trunking protocols, static and dynamic ether channels, and then common spanning tree protocols like rapid spanning tree, multiple spanning tree, and then root guard and BPDU guard, right? You take these concepts, it's like, okay, how would you lab that up? Okay, well, let's start there, and we'll build a topology from there. So let's come over here, and I'm going to go ahead, I'm going to close this guy out, and I'm going to go ahead and add in here, we'll do RRTC Whiteboard Wednesday lab build. And what I'll do is I'll create this, and I'll put it out, once the video has gone, once we're done with the live, I'll throw this topology up inside of Google Drive, and then in the description of this video, and probably pinned in the top comment, I will go ahead and put a link to the Google Drive. So if you guys want to download this topology once I'm done building it, you guys can test it out. So going back over here, we're going to be taking a look at 802.1q trunks, ether channels, and spanning tree. So what's the first thing we're going to need to do? We're going to need to come in here, and we're going to need to grab a pair of iOS switches. I'm going to grab 3 of them, because in order for spanning tree to work effectively, you need at least 3 switches. And we're going to go ahead and put in 3, and we're going to go SW capital for switch. We're going to click on save, and then we'll put these into a triangle formation. Why a triangle, you might ask? Well, because that's how spanning tree is designed to work. You want to build triangles, not squares with spanning tree, or else you will run into issues with that. And if you're not sure what that means, let me go ahead and just link these guys together. We'll talk a little bit about why triangles over squares. So if I do this like so, and we click all these guys together, so this is what you want to build. This is a best practice design for what you're trying to move forward with. And you want to build it like this so that your uplinks are always active. So if you're here at switch 3 and you've got devices attached to switch 3 that are attached to access ports on the south side of switch 3 where my mouse is right now, if that is what you have, then you want to make sure that gig 00 and gig 01 are both actively forwarding traffic. So here's the thing. They're gonna actively forward traffic on a per VLAN basis because that's how spanning tree works. Where this link in between switch 1 and switch 2 doesn't get used unless one of the uplinks to switch 1 or switch 2 were to fail for some reason. And this guy right here is the root bridge for a specific set of VLANs, and this switch is the root bridge for a certain set of VLANs. Sorry to interrupt you as your but what are some reasons you prefer EVE-NG over GNS3s? Oh no, you're good, Keith. I hope I'm saying that right. I'll say KT for short, just because of the fact that it's I don't want to butcher your name. A fair question, and the reason why I deal with EVE over GNS3 is simply for the fact that I used GNS3 for a long time, and to me there was limitations back when I was using it. And this is probably like 8, 9, 10 years ago. I've had it always installed on my computer locally to demo as a part of the evolution of labbing, but I've always had better luck with EVE-NG than I've had GNS3. It literally just comes down to personal preference. There's nothing wrong with GNS3. If you guys want to use it, by all means, go right ahead and mess around with it. It just personal preference is really what it boils down to. So, but yeah, you're good to go, man. So I know someone's going to mention, well, you can't be active on both interfaces on switch 3, and that's true. And that's because there's always going to be one port that's going to be the root port. So if this is, for example, the root bridge for VLAN 11, and I always try to pin my odd-numbered VLANs to the odd-numbered switch and the even-numbered VLANs to the even-numbered switch. Just makes lab building that much easier. No worries, KT. No worries at all. If your root bridge is on switch 1, then gig 01 is always going to be blocking, right? That's just going to be how it is. And if switch 2 is the root bridge for VLAN 10, then gig 01 will be forwarding and gig 00 will be blocking. That's just how it's going to work. Now, you always want to build in triangles. You don't want to build in squares because you're going to have that many more ports blocked. That's a simple rule of thing. You just don't want to build that out. If you look at spanning tree documentation and spanning tree design, they always tell you to build in triangles, not squares. If you really want to dive into the technical stuff, there's some pretty decent design guides out there. And if you look at the configuration guide for like the older iOS switches, the 3750, the 3850, they have some decent detail on how that comes into play. All right, so we've got our triangle built here. Then the next thing we want to do is our ether channels, which means we need to have 2 links connected between the 2 switches. So we'll go ahead and go grab this guy right there. So we're going to add that port there, and then we can put switch 1 and switch 2, we can put a port channel between those 2 switches, and we'll be in good shape there. Whether it's PAGP, LACP, or a static port channel, it really depends on which way you want to go. You can test all 3. The only thing that I have not had good success with on these switches is trying to do layer 3 port channels, but it's one of those things where your logical interface, your port channel interface port channel 1, for example, that would be converted to a no switch port command, but it doesn't seem to work out here. At least that's been my experience. So anyway, so we've got that built. Now the next one going down is spanning tree enhancements like root guard and BPDU guard. As long as you have your triangle built in your topology, then you're in good shape there. Root guard, BPDU guard would be configured at a per switch level. Root guard on your root bridge, obviously, to protect it from being overtaken by another root switch, stuff like that. Now, when it comes to compare routing concepts, it talks about in advanced distance vector versus link state, load balancing, path selection, path operations, yada, yada, yada. Then it says simple OSPF v2, v3 environments. I will be honest with you, as I've been going through an Encore and a NARC practical workbook for that exam, I have noticed that on the switches, the version of code that I'm running doesn't support OSPF version 3. So I want to do IPv6 for it, but I would be forced to do EIGRP or RIP, and I don't want to deal with either one of those. I have a rather large topology for multi-area OSPF, and unfortunately OSPF v3 doesn't work on that particular version of code. So no harm, no foul. But what we'll do is we're going to drag this guy down here a little bit, and we're going to go back over here, and we're going to configure a simple OSPF v2, v3 environment with multiple normal areas, summarization, filtering, neighbor adjacency, point-to-point, broadcast, and passive interfaces. Okay, so what I'll do is I'll come over here, I'll grab a handful of iOS routers, and I'll grab 4 of them. Actually, no, I'm going to grab 8 as I'm thinking about that. We'll grab 8 and we'll build out a multi-area OSPF topology. So as you can see, it doesn't take much in order to start getting this thing a little bit complicated. So I'm going to drag this guy over here, and we're going to put 4 here, put 5 here, and we'll put 6 up here, put 7 there, and then we'll put 8 over here, then we'll put 9 over here, and then we'll put 10 up here, and we'll put 11 over here. Now the idea here, if we were to, let me link these guys together real quick, and I'll start drawing some boxes to try to highlight why you would do what I'm doing. So what I'm trying to facilitate, I don't want to draw it between those two. What I like to do is, in order for you to do multiple normal areas, it says nothing about stub areas, like stub, totally stub, or not so stubby areas. So what it wants you to be able to build out is just normal areas. Well, that's great for Encore, right? But if you dive into a NARC and we look at layer 3 technologies, one of the things it talks about is multiple area types: backbone, normal, transit, stub, not so stubby area, and totally stubby area. So what my brain, because of the way that I've learned the routing technologies, has automatically gone to, whenever I develop even a small OSPF lab, I always have to add in virtual links, passive interfaces, stub areas, and all the different stub types. And it's one of those things that just keeps the knowledge fresh, and I remember how to configure this stuff basically off the top of my head. So we have our normal area, right? Well, what we're going to do is we're going to come down here, and we'll link these guys together. And then, if you can't visual, it was an absolute pain learning the LSAs. You're not wrong, man. You're not wrong at all. It's one of those things where it's a lot of repetition, and I can't remember what the trigger for me was in order to learn that stuff. It was just more or less a repetitiveness to learn LSA 1 and 2 always stay within the area that they're in. If you convert all the interfaces to point, then you automatically remove type 2. Type 3 is on the ABR and generated for routes in another area. Type 4 is generated by the ABR going to the ASBR. And type 5 is if you redistribute anything into OSPF. So these are just some things that come into play. Now, actually, as I'm looking through here, have you seen virtual links in production? Once I did a long time ago, and funny you actually say it was a Band-Aid. It was from a merger and acquisition at the time, and they had just gotten done doing the acquiring part, and they set it up in order to bridge OSPF, and within a month it was gone because they didn't want to do a whole bunch of redesign in order to get something to work. So you're right. I'm going to go ahead and add in another node here. I'm going to go ahead and add in a few more routers just so I can stay ahead. We'll say 4, and what we'll do is I'll bring 12 over to here, and we're going to connect these guys together like so. All right, so let me go ahead and start putting these together in some boxes and give you guys some highlights as to what we're trying to do here. And I'm kind of OCD about how I like my labs to look up, so I like everything to be lined up appropriately. So pardon me while I do some alignment here. It just is the use of virtual links an exception rather than a rule in terms of its use good for a temporary migration? Yeah, I would say it is much more of an exception. It's the one time that I've seen it, it literally, I was like, wow, you guys have a virtual link deployed. Because the way that I was looking at a network diagram. I hadn't even logged into any equipment yet. And the way that they were explaining their topology to me, and I'm like, well, the only way that's going to work is if you have a virtual link. And it was funny because when I said it that way, I was looking at like a Visio that they had printed out on a big piece of paper and put it up on the wall in a conference room, where they had a bunch of us consultants looking at the network diagram, and they were going over it. And there was probably 10 or 11 people in the room besides myself. And as soon as I said that out loud, I had like 8 people look at me and go, "What's that?" And I had to like explain what a virtual link does and how it's it's one of those things where it's there to fix basically a bad, I didn't use the term bad, a poorly designed or modified on the fly OSPF design. And I had a director look at me and go, "That's actually a really eloquent way of telling us that our network sucks." So, and he laughed about it because he knew it was a joke. But yeah, those things do come into play. But I've only seen it once because, to be honest with you, most enterprise customers that I've worked with, they don't run OSPF in their core. They run EIGRP. So, all right, so let's start putting some shapes in here so you guys can see how this design is going to come into play. Actually, let me go ahead and edit this and make this. Can I? Oh, I screwed up. Border type. Nope, my bad. Let me go ahead and delete that one real quick. We'll go custom shape. I like rounded corners. They just look better. Solid. We'll go down to 3. All right, so we'll take this guy, and this guy right here will be. We'll do area 0 for all this, and I'll explain why I'm doing the links the way that I'm doing them. If you're not sure or don't follow along right now, that's okay. I'll explain it here in just a second. But it'll make sense here in just a minute. Okay. And then we'll duplicate that. And then we will bring this guy up and over like that. And one more. Let's bring this whole thing. Why did I not grab? Okay, there we go. All right, and then we'll do this one here too. All right, so the way that I have this topology built out so far, if it doesn't make a lot of sense, that's okay. Let me move this guy over here just because of the fact that it's gonna bug me that it's lined up the way that it is. Okay, so what I would do here in the middle, we go ahead and grab a text box, and we're gonna say this will be area 0. And then we'll grab, come here you, put this as area 0, then we'll duplicate it. And then, so for those of you in the chat that do know what I'm talking about when it comes to area 0, tell me what area 0 can only be. What is the only area that area 0 can be? If you know the answer, throw it in the chat. So we'll go ahead and finish up doing these guys real quick. We'll do 1, 2, 3 for short. No takers? I figured somebody would have jumped in right away. And then we'll do this guy up here. Okay, the only area type that area 0 can be is a regular area. You can't make it be anything other than a regular area, in case anybody was curious. The backbone. Yep, area 0 is the backbone. You are correct. Yeah, you guys are just, it might have taken a little bit longer to get the question to you guys and for you guys to process. Okay, so the way that you would break this out is you would do area 1 would be a stub, and then you would have this guy right here would be a totally stub, and then we'd have right here, you'd have this guy right here would be a VL for a virtual link between these guys, and this guy here would just be a normal, we'll say just an internal, because it can't be a backbone because it's not area 0. So let me explain a little bit about how this is going to come together. Correct, the backbone. So area 0 is your backbone, and everything itself connects back to the backbone, right? Everything, all non-zero areas have to connect back to area 0 in order for OSPF to do its job, right? Everybody, if you don't know basic OSPF, that is what's needed in order for it to work. Okay, so now we've established that. The next thing to do is, if you don't want to receive any type 4 or type 5 LSAs in your OSPF database, then you can throw area 1 into stub area. So it'll only accept types 1, or area 1, LSAs 1, 2, and 3, right? So R11 on both R5 and R11 could be stub type, area 1's type stub. I take it a step further where I do these R7, 10, and 12 are configured to be a totally stubby area. So this is my area border router, right? R7 is my ABR. I put totally stub. So totally stubby means that you don't generate a type 3 LSA into the area. You do just a stub no summary command. And then R10 and R12, they would both get the stub command. And then on area 123 and area 89, in order for area 89 routes to get propagated into area 0 and the rest of the OSPF domain, and for everything in area 0, 10, and 1 to get pumped from area 123 into area 89, you need to configure a virtual link in order for that to work. So we would configure a virtual link between 4, 6, and 8 based out the router IDs. So whatever the router IDs, you just do a virtual link between those boxes and go through all that. And the key thing with virtual links, they can't be another stub type. They have to be, if they are, they'll automatically bump the cost to 65535 and it won't work. So you've got to keep that in the back of your head when you're designing your OSPF domains. Let me go ahead and move that over just a little bit so it's a little cleaner. This is where the OCD part of me triggers. So that's, if I was going to design an OSPF topology to test out both Encore and NARC topologies, this would basically be the smallest topology I'd be able to build. Now, for switch 1 and switch 2, they're part of area 0, but what I would do is for the SVIs that are going to sit on switch 1 and switch 2, those subnets would be considered passive interfaces. I would not allow OSPF adjacency over the port channel, and because this switch only has 2 egress points, switch 1 and switch 2. So it'd be a little bit different if I had a cross connect between 4 and 5 down to switch 1 and 2, where there's connections down here and a connection down here. That'd be a different story. But for the most part, I've set up a lot of networks just like this, and there's really no need to do any additional cross connects. You can, but it's not really going to give you a whole lot of extra connectivity. It's more likely that a node is going to fail versus a link to fail. All right, so now that we've done that, now we have a problem now. What's our problem? If we look down here at the next topic, it says configure and verify eBGP between directly connected neighbors, best path selection, and neighbor relationships. So how do we build in a connection to that? So, and actually there's one additional stub type that I'm actually forgetting to do, and that's called the not so stubby area, which we could convert one of these areas to be that. And that's one of the things you have to be careful on when you're doing OSPF design. So I don't want this really to be an OSPF design video or live because it gets complicated quickly. But one thing you could do is you can connect right here. Come here, you. I don't know why it does that. You can connect this guy here. We'll say this could be anything, right? So you can connect here, and we'll say save on that one. And for the sake of argument, do I want to do another? No, we'll keep it the way that it is, because technically R7 can then be an ASBR, an autonomous system boundary router, where we can have an eBGP peer going out to R13, and we can have a loopback on R13. Or if you really want to be special, you can connect 13 to 14 and have. Okay, why did you not connect? There we go. You can have R14 create, say, 10, 12, 15, however many loopback addresses you want to throw on there, and then advertise them into BGP. R13 gets them, and then R7 gets them via eBGP, and then you can redistribute those routes into OSPF, and then you'll see a bunch of type 5 LSAs generated for all those external routes. So we have that piece. All right, so that pretty much takes care of Encore for all the routing topics. And then you can start taking a look at like NAT and PAT, first hop redundancy. So where would you do first hop redundancy? Let's do that. Let's work our way out of the network. Well, the first thing you do is, and you can do this on either one. You could do this on switch 1 and switch 2 at the SPI level. That's one place you could do this on. Or if you wanted to move the routing domain up to be where router 4 and router 5 are your gateway devices, you could configure subinterfaces on R4 and R5 to do first hop redundancy as well. Router on a stick, as the concept is, and you just configure gig 3 on both switch 1 and switch 2 to be a trunk link. And then if you want to do HSRP, VRRP, or whatever, you can configure those on the subinterfaces, and as long as they can communicate back and forth, you'll be in good shape. So it can go either way, and typically that's actually how I like to do my if I'm teaching layer 3 gateway connectivity, that's how I like to do it. I start a router on a stick, and then I migrate to, I do layer 3 switching with SPIs, and then I migrate over to router on a stick. So we'll keep this guy down here just for the sake of ease and understanding for all of you guys. So we have that. All right, there we go. Okay, so that's how you would do that. That can go either on switch 1 and switch 2 or R4 and R5. It will work on both. And then we have things like NAT. So where would you do NAT? Well, NAT, you'd probably do that on R7, because that's your egress point off to the rest of the network. So you could do NAT on R7 and go about things that way. So would you need BGP still? You would, because you can't take your private address space and dump it on the internet. So you'd still have to do some sort of configuration on R7 in order to make that work, and you'd be able to NAT out to the internet and all that good stuff that goes along with it. So that's how you would do NAT and PAT going from there. And just remember that NAT is 1-to-1, PAT is overload, where you're taking a single public IP and you're using a bunch of port numbers to do all your port address translation. So there's that. So we've taken care of layer 2, taken care of layer 3, BGP. Okay, PBR. So let's go back over here. And what I would do with PBR, come here, is I would connect, let me go ahead and scoot this guy up just a little bit just so that it's out of the way. Come here. Scoot you up just a touch. Okay. What I would do is I would configure R15. Oh, I'm out of interfaces. So let's go ahead and edit that real quick. And okay. So what I would do here is I would configure policy-based routing. Are they specifying the iOS for NAT, PAT, or can it be the ASA? In this particular case, this is going to be on a router. So they're expecting you to be able to configure NAT and PAT on an iOS router. So although I would be configuring it on a firewall to do, at a minimum, an ASA, but I would put a firewall on your internet edge as a best practice, but in this case here, you need to be able to do it on a router. So that's where that would come into play. And then for policy-based routing, what I would do is I would have a PBR where traffic coming in on gig 0/0 or 1 or whatever interface you want it to come in on. You can configure a 100, yeah, for sure, exactly, on the power thing. you can configure all these interfaces, gig 2, gig 0, gig 1, to have a PBR set up. And PBR, policy-based routing, is access list, a source-based ACL, like so in standard ACL, called by a route map, and then that route map is then associated to the interface through a policy IP policy command. And what that does is it will look at the access list and the route map first in its order of operations processing. And what it'll do is if there's traffic coming from a specific source, it will automatically route that traffic to whatever next hop IP you tell it to go to. That's what policy-based routing does. So it's source-based routing, where if the traffic doesn't match the ACL, it'll bypass the route map, and then because it won't match the ACL, it won't get processed by the route map, and it'll drop down to the routing table, and then from the global routing table, you basically do a show IP route, and it'll go wherever the routing table tells it to go. So that's what PBR is going to do. So I would add this in here for PBR. So you could have specific traffic going to PBR. Maybe this is a PRI for voice, or it could be all kinds of different scenarios if you wanted it to be. It just depends on the means. So that's how I would handle that. Describe multicast routing protocols. So RPF check, reverse path forwarding, PIM, IGMP v2, v3. So v2 is IPv4, v3 is IPv6. So with that particular case here, you could do multicast here. As long as there's end-to-end IP connectivity and it's loop-free, you're good to go. So you would enable multicast globally, so IP multicast routing on all your routers, and IGMP snooping on your switches. And then you would enable PIM sparse mode at all of the link level. Once you do that, then you're going to have to configure at least one of these routers as to be a rendezvous point. Your rendezvous point is going to join together your source tree, so traffic coming from the source of the multicast traffic, and then you also have the shared tree, which is all of your receivers signaling to the network, hey, I want multicast traffic. So what will end up happening is, let's say we have R4 as our rendezvous point. We'll configure whether it's auto RP, static RP, or BSR, a bootstrap router. We'll configure one of those three mechanisms as your rendezvous point. Whether it's auto RP and BSR do it automatically, so it does a propagation of information. I prefer BSR over auto RP personally. It's a little easier to work with. Doesn't have the gotchas that auto RP does. So what you would do then is, let's say for example R9 is your multicast source, and let's say R11 is your receiver. So you would configure, and maybe we have a host down here. So let's go. I'm going to add another router here real quick, and we'll just call this guy here. We'll say this is PC1, and then we'll say desktop. And we'll click save, and then we will connect him to there. So we configure PC1 through whatever mechanism, and you can do it in iOS. You can like gig 0/0, for example, you can type in the IP address so that it can talk to its gateways, and then you can say IP IGMP join group, say 224.1.1.1. And then if R9 sends a ping to 224.1.1.1, which is a routed multicast group IP address, then that traffic would hit the RP, and then PC1 would register with the network, and then R4 would join the shared tree and the source tree, and then traffic would flow through the RP to get down to the PC. And then there's a shortest path tree switchover process that kicks in, which in this case here R4 is still in the data plane, but if R4 was not in the data plane, which is highly unlikely in modern multicast, you would end up sending the traffic to R4 anyway because it's in the data plane. If it's out of the data plane, then the rendezvous point, the RP, would only be responsible for handling multicast control plane. Would be stitching the shared tree to the source tree and making it the shortest path tree. Shortest path tree meaning the shortest path between the source and the receiver. So the traffic would go R9, R8, R4, switch 1, switch 3, PC1. That would be your shortest path tree. So that's a real quick high-level overview of how multicast would work in this environment. So there's that. And then you have some other options that are come into play here. You can't do span on virtual switches. I don't care which one it is, span or ER span, which is encapsulated remote span. And span is switch port analyzer. So it allows you to copy traffic from one interface to another on a switch port and allow it to be analyzed through Wireshark and things like that. You can configure IPSLA. So for example, if you were to come over here on R7 and do an IPSLA ping to R14, and then if something were to happen where there's a default route on R7 pointing out towards R13, only if the traffic is reachable on R14, so an IP address on R14 is pingable, then traffic will continue to go this path. If not, then you can configure a reliable static default route where if the IP address on R14 is no longer reachable, maybe you shut down the loopback, for example, then you'd be able to, the SLA would fail, the tracking would fail, then the default route would get yanked, and the traffic would go via R15 instead. You could do stuff like that. So that's how you would do IPSLA. So an IPSLA is simply an operation, and all it does is it pings something, or it sends synthetic traffic, and it tries to mimic a particular type of traffic, like it could be a voice codec, like G711U law, G729, stuff like that. And security, there's a little bit in here that you would have to be knowledgeable on. AAA, which is authentication, authorization, and accounting. Then you have access lists, control plane, policing, and protection. So you'd want to go through and demo all that. All that stuff can be demoed at the device level and stuff like that. So that's how you would test out Encore and a good portion of an RC. So an RC, you'd be able to take this a step further, and you'd have a whole lot of other stuff. So you do EIGRP. So you could take this topology and rip out, let's say, for example, you could take Area 123 and Area 89 and you completely rip out OSPF and replace that with EIGRP, and do R6 and R4 would be mutual points of redistribution. And then you'd have to worry about our friend route tags and making sure that you don't get route feedback through redistribution, which is a real thing. So you have that you can work with, and then you can configure R9 as a stub so that there's nothing southbound of it. And that's essentially what a stub is. It means that there's no other routing devices logically south of me. I'm an edge of the network in some respect. So you can do that. VRF Lite, we haven't talked about VRF Lite, but you could, if you wanted to, configure VRFs on these routers everywhere in the network if you wanted to. And VRF Lite is the ability to use VRFs without MPLS. So you could definitely pull something like that off if you wanted to mess around with it and see what that's like. VRFs can be done, typically I like to do them in like squares or triangles, so that what I would do is you can run, it's a loosely analogous to multi-topology mode, where multi-topology means that you would configure sub-interfaces on these interfaces. Like gig 0/2, you would do like 68, and then 46, and then 48, or whatever you wanted to come up with. And then you could throw them into a VRF, and then you could run OSPF Area 123 here at the physical interface level, right, the actual main interface, and then you can run EIGRP inside the VRF. Kind of cool what you can do with it, if you know what you're looking at. So if you didn't know you couldn't do that, then there you go, you could. Because a VRF is a completely separate routing table. It's a user-created routing table. So you'd be able to basically demo out whatever you'd like, and there's really no limit to how many VRFs you can create. So create 30 of them if you wanted to, and create 30 sub-interfaces and have multiple instances of OSPF and EIGRP, BGP, RIP, ISIS. You can go as far as you'd like to take it. So pretty cool there. So, and then you have EIGRP, right? You could demo that all out. So basically the topology that I've built out, you can demo pretty much anything you'd like to with it. BGP gets a little bit more interesting because of the fact that you have more moving parts to it, but you could take this topology and break it up into other, like these could all be autonomous systems. Every router could be its own autonomous system, and you could do one big BGP design and deployment and lab it all out. So what I've built here is a fairly basic topology that you could demo out basically almost anything you want for Encore and an RC if that's the direction you want to go. And this would be a good starting point. And I'm not getting any more specific on my nomenclature for anything because the reality of it is that you want your labs to, for the most part, to be as flexible as you can make them. Because if you lock yourself down too much, you're going to have a hard time pivoting to another topic. So you want to keep things as loose as you can. Make sure you take whatever you're configuring. I like to keep a Word doc open of whatever I'm working on. So if I'm testing out a particular capability or a feature, I will test that feature out and I will take the config out of the device that I'm working on if the ability to pull in the config via the CLI off is there, and I will dump that into the Word doc, and then I can put any notes in there that I want. And that gives me the flexibility of if the lab loses power or I power it off for some reason or the router gets buggy or what have you, I'm not sitting there going, oh crap, now I have to spend X amount of time rebuilding it. Nope, all I have to do is get the box back online and then copy and paste the config that I just had on it back in, and I'm back up and working in just a matter of a couple of minutes. So it definitely saves you a lot of time. And it doesn't have to be Word. It could be OneNote. It could be Evernote. It could be Notepad. As long as you're keeping track of what you're configuring and what you're working on. Because when you transition from Encore to an RC, you notice that there's a lot of troubleshooting, right? Same thing with, there's a lot of troubleshooting. So the NRC exam is a replacement for the CCNP T-Shoot exam that I had to take. So where your job is to figure out what's broken and then try to fix it. So when you get into these troubleshooting scenarios where you have to be able to troubleshoot all this stuff, you can't troubleshoot something you don't know how to configure or verify. So you have to understand how to configure and verify everything first. Then you can go through and be able to troubleshoot it. Because you have to understand, okay, how do I verify it? What are the things that I'm looking for a known good configuration versus a known bad configuration? Or what's missing or improperly configured, things like that, so that I can go through and identify the problem. For one, we gotta figure out what's not working or what's not right, and then once you identify those things, then you can fix them. And until you get there, troubleshooting is going to be that. It's going to be troubleshooting. You can't fix something if you don't know what's broke. So, which is why I tend to take if there's something I don't know, I take it to people that do know what they're doing. Like a mechanic. So, another one is DMVPN. This seems to be something that a lot of folks struggle with. In my experience, most customers are not moving to a DMVPN design. They are moving away from it because it's so old and so legacy. Your opinion, should they take SNMP v2c and time-based ACLs off? Sure, every environment is different, but have you seen them in the real world? I have, quite a few times. Time-based ACLs are still good because, well, they're based off the time and they do work. Anytime I get an opportunity to, I will automatically go with V3 because there's authentication and authorization. You got a higher level of security associated with that. But when you're looking at things like access lists where they're time-based, as long as you understand the difference between V2C and V3, and then all these different variations of ACLs, you're in good shape. So, I know your question was real-world driven, but there's it's not very widely done. It's more of a somebody threw something in because there was a need for it at the time, and that's going to be networking in most cases. So something, a configuration change was needed in order to get something to work, or to um, to deny or forbid traffic of some type from getting somewhere, whatever the driver was. That's usually why that type of stuff was put into play from the get go. So, and ironically, you're probably going to walk into environments at some point in your career, especially if you work in consulting, where the person that did that is no longer there, and the people that are there to maintain and monitor that, they're like, it was here when I got here, so I don't know. I still see old stuff in production and shutter. Yeah, you're not the only one, man. It's part of it's networking. You see stuff and you're like, I remember back when I was studying for route switch. This is 2013-14 time frame, and I remember walking into an environment. The environment had a PBR to a GRE tunnel, and I forget where the GRE tunnel was going to. It was a remote site, but for some reason they thought it was a better idea to PBR the traffic to a GRE tunnel, and then from the tunnel, it went somewhere else. So, yeah, it was very, very weird. I came across something called NVI. Do you have any idea what's the difference between it and a normal normal NAT? Well, the NVI is the NAT virtual interface, and as far as I'm aware, they're the same thing. I can't really. I don't know the difference between NAT and NVI, if there is anything. That's a good question. I don't know off the top of my head. I have to dig into it. But that's typically only a router thing, and at least over the past 4 or 5 years, I haven't seen routers doing NAT. Now, what I will see, and I'm going to draw this out real quick just so you'll have a visual. What I have seen is, we'll take 2 Palos, is this, where you'll see Palo firewalls. There will be some sort of high availability switch sitting southbound of it, or northbound of it. So we'll grab 4 of these. I've seen this a lot lately, where you'll do like a switch sandwich, and then there will be routers. Grab 4 more of these guys. You'll see this. And what you'll see is something like this. So I'm not going to link these all together because this will be kind of a time-consuming thing. But you'll have connectivity southbound to switch 19 and 20 that'll be pulling traffic into the switches, right? And then you'll have a pair of firewalls. And the inside, the bottom half of the firewalls will be the inside. And then they'll NAT to some public address. And everything, let me grab this real quick. So all of this right here, the top half of the firewall will be public. The bottom half will be private. And the firewalls will be doing a combination of both private and public. So the top half will be all public. This will be an address space that the customer owns. And then there will be BGP peerings from 25 and 26 to 23, 24, or a default route or static routing of some type. And then the firewalls will have a default route pointing towards an HSRP VIP of some type. And they'll either connect to 25 or 26 depending on who's active and who's passive. So that's something I will see a lot of. I don't ever see routers doing NAT anymore. And if I did see that, I would be calling red flag on the play right away. Like, you need to get that thing out of there. It's just a matter of time until that thing gets hacked, unless you're actively patching the router. And even if they are actively patching the router, routers are stateless unless you turn on things like zone-based firewall or some security features, but routers were never designed to be firewalls. You purposely buy firewalls to do firewalling things and stuff like that. So that's what I would do, is I would do some sort of design like this, especially if we need high availability. That's what I would be doing. Do you see EVPN replacing or complementing MPLS? So EVPN itself, if we're talking, you need to be able to stretch traffic, and I'll grab a couple of 9Ks out just for visual purposes. If we take Nexus, we take these guys out like this, and we'll take 29. If you do something like this, where you've got 27, these guys are connected together, and then you have a spine leaf architecture like this. Do I see... So inside of a customer's environment, whether it's their LAN or their data center, no, I don't see MPLS replacing any of that. You would be surprised how not common MPLS is outside of a service provider environment. Now, there are exceptions to that rule. There are customers that I have worked with that do MPLS in their core, but their intention was to leverage things like MPLS fast reroute, which is a complicated thing for most people to get their head wrapped around, and typically you only see that in hyperscalers like LinkedIn, Google, Facebook, that would need super high speed failover. But in most customers, you're not going to see that. Now, what you would see is VXLAN EVPN. You would see that. And you would do 28 and 29 would be talking to each other and go from there. It is what it is. MPLS, technically speaking, VXLAN EVPN, there is a label. But it's whether you're doing VXLAN EVPN with BGP, because VXLAN is the data plane, EVPN is the control plane, because you're using the EVPN address family in order to do the communication via multi-protocol BGP. So you have that. So I see it more in service providers that have data centers attached to them, maybe, but in most cases, no. Especially not replacing MPLS. You still need a transport mechanism between the devices. Watching Cisco Live? Anything you're looking forward to from that? I am going to Cisco Live. I will be there in June. So if any of you guys are going to be there, maybe we'll meet for the first time. That'd be kind of cool. I have a list of I'm still working through what sessions I want to go see and go sit through. There's also a lot of stuff that I won't be able to go to that I want to. So I'm making a list of all the sessions that I want to go see. So definitely looking forward to it. It'll be the first time since 2019 since I've been there. Do you see FHRPs used in core? Because I see it and I was thinking it's design mistake. Am I right? In my opinion, it depends on the scenario. So it's one of those things where you have best practice, but just because best practice is best practice doesn't mean it's always right for every scenario. So you have what most people are comfortable with and stuff like that versus what's actually needed in order to get the job done. So best practice to me only goes so far. I will follow it as far as I can until it's either hindering me or, well, in that particular case, it's hindering me from meeting the customer's objectives. So if the customer comes to me and says, I need XYZ to be able to work, or I'm trying to get from A to B, and as we're walking through the design, because remember, I'm an architect at the end of the day, if we're walking through the design of what they're trying to do, and best practice, as I'm going through best practice and I'm like trying to do a sanity check, and we're keeping the train going between what the customer needs and what best practice would do. If that starts to clash or it doesn't work anymore, I'm like, okay, well, I need to pull best practice back and say, okay, what can we do in order to get the customer where they need to be? So that's how I look at it, because I have had to call TAC on issues, and they've looked at what I've got in play, and they're like, wow, this is weird. I've never seen it done this way before. And it's just like, okay, well, just because you've never seen it done like that doesn't mean it doesn't work. So it's one of those things where you've got to meet the customer's objectives, right? That's what you're there for. So I'm all about best practice until it prevents me from getting the job done or it starts to hinder me. So if it if you're seeing that and you're like, what are these guys thinking? Or it goes back to what Matthew was talking about earlier when it comes to using virtual links or what was the other thing that you mentioned? Virtual links. So, you do things because you have to, not because you want to, or to get the job done. And I'm sure you're picking up what I'm putting down at this point. So that's pretty much that's how I see it, because it makes Cisco Tech, it was the best times. It was the most frustrating of times. Yep, that is very, very true, man. It's one of those things where you gotta it's a love-hate relationship. You hate to call TAC, but you also want your stuff to work, so you don't have to sit on that call anymore to try to fix it. And I don't know if it's gonna pick up on it here, but let's say if you guys know the let's say if you guys, is this it? Anybody recognize that? Yeah, I won't go any further with that, but if anybody recognizes that, and I'll put the go to this link, and if you don't know this, then you've never sat on hold a while with TAC. So, been there, done that, and yep, oh yeah, the CUC of hold music. You know exactly what I'm talking about. Yep. All right, I've seen a lot of yeses. Yep, that's exactly what I'm talking about. I've sat on hold with that music forever, to the point where I'm sitting there at my desk and I'm like jamming to the music and playing the drums because I've got the timing down. So anyway, that's it for this evening. I'm gonna go ahead and go from there. I'm about to go work out. So unless there's something else you guys have questions on, or there's something else you want to chat about, I'm happy to stay on for a few more minutes. But figure that's good stuff there. Upcoming video network enterprise network series. So the enterprise networking series with the videos that I've released so far, I'm not going to release anything after what I've released so far. Just the view counts aren't there. So what I will be doing when it comes to any of the stuff that I'm working on, I will be flipping over to if you've bought the enterprise workbook, as soon as I get done with the NARCI and Encore workbook for that exam, or for those exams, as soon as that's done, and I'm hoping to have that done before I go to live, so I've got basically 5 weeks, and I'm trying to get that done before then. So it's completely done. So the workbook is like out and live for you guys to buy. What I'm planning on doing is taking the workbook, and I'll be doing a bunch of videos on walking through how everything's supposed to be stood up. So I'll literally take the workbook, and I will, it'll be a video companion to it, and be walking you guys through how to get everything up and working, the technical deep dives on how stuff works, why it's set up the way that it is, all that type of stuff will be coming for that. And I'm planning on doing that for every workbook that I do. It'll be the workbook first, followed up by the video series. And the only way you guys will be able to, I'll take a small percentage of those videos and I'll put them out on YouTube. But if you want the whole thing, I'm going to be flipping over to it'll probably be like $25 a month for Okay, yeah. So what I'm the pay so funny you said. Um, so the way that the it works is if you buy the workbook, any workbook that I write, that I produce and make put on Patreon, the workbook itself, the targeting price across the board for all of them is going to be $50 per workbook. It's a one time payment. You have it. It's yours for life. And then if there's any if people point out issues in the workbooks, I try to do my best to make them as accurate as possible. But there's also going to be a $25 a month membership that I'm going to do to where you get access to everything. It's going to be the workbooks, the videos, and the topologies. Um, but the if you've all if, it's $10 a month for access to the topologies. So if you I started that on YouTube, but then there was a handful of people that didn't have access to it through YouTube Join. So I created the Patreon for that, and so I just started using Patreon for everything in that respect because it's already there. So that's how that's going to work out. Um, when you say SVPN, are you talking the service provider? Let me go back to, I think that's what you mean, service provider. Let me go back one more here. I think service provider VPN is the one you mentioned, or is the one you're referring to. I have to go back and check. No? Are you talking security VPN? Maybe that's the one you're referring to. Security VPN. Okay. Oh, would help if I could get to the right track, huh? So, it's actually one of the other ones that I'm going to be developing as well. Yeah, so you're talking about this one. So I plan on putting together a workbook for this one as well because it's an area that, yeah. So I'll be creating content for this one as well. Um, yeah, it's a lot of VPN stuff. So, yeah, I'll be going through this as well between ASA and routers and going through all that. I took the security VPN exam. God, what was that? Probably 4 years ago. It was a butt kicker. It was not easy to pass. I scored really, really well, but I definitely do plan on putting something together for this because there's nothing really out there for it. Yes, yes, yeah, dude. You and I are gonna get along just fine with the way you're saying stuff in the chat. Your personality, and mine are gonna get along just fine. But yeah, there's a lot that goes into the VPN side of the house. I also want to go through and do one for uh, ASA because it's on the security CCIE, the firewall one. I would have to mess around with web and email because the fact that I don't deal with those on a regular basis. But I definitely am going to go through. My goal is to go through as many Cisco technologies as well as Fortinet, Palo, SD-WAN, what else? Cloud, VMware. So I plan on going through a bunch of different technologies and writing workbooks around them, so that there's content out there, and it just helps me learn. Right? I'm a glutton for punishment, if you will. So I definitely plan on doing all this, but the drawback to it is it just takes time. I wish there's not a. I wish I could clone me and just have one of me in the corner, just pounding away on the keyboard all day long on workbooks. That would be. That's. Yeah, I completely agree with you on that. You donated money to Cisco on your first attempt. Yeah, it's one of the it's yeah, exactly. I'm right there with you. I plan on going through all these exams for all the different tracks, as many as I can demo out and learn, because the fact that I just want to learn them, it keeps me out of trouble, gives me something to do in my downtime. So I've always got something I'm working on. Let's see, is it right here? Yeah, it's this one here. I don't know if you were here when I first started up, but I do. Whoops, let me close this one out. which one is this? Is it? No. It's one. Yeah, so my goal is that when I start releasing the videos here, once I get a NARCI, an Encore workbook done, I'm going to pause workbook development, go back and record videos so that I can be workbook development and building out videos at the same time. And so that they get released basically within a little bit of each other, and $25 a month would get access to everything. It's going to be the all access pass, $25 a month, videos, workbooks, topologies, the whole 9 yards. So it would be one price point across the board. I'd still release the workbook at the $50 a month in case you don't care about the videos or anything like that. So yeah, that's what my game plan. Last one I promise. Have you ever gotten ASDM or the ASA webpage to work inside of Eve? Yeah, a bunch of times. I would have to. What was it? What did I have to do? I have a Windows 7 image from a long time ago. I had to take that, deploy it as a Windows VM, and then I had to go and there was Java Shockwave, some combination of Flash Shockwave Java that I had to install on the Windows 7 box, and then once I had that, then I was able to log into the web. So actually, I'll show you here real quick, just because it's literally right here. And all I did, I think I have ASA in this one here. I do node, and I do, yep, right here. That's fine. And all I did is, go ahead and turn that off, is I would connect this to network. I'll just say management for short. And all I did was connect this to the management port and save. And then I would boot it up. Yeah, same. I have an ASA 5525X as my home firewall, and as long as you configure the management port, that's all I ever did. And so when I do start to mess around with Java on the ASA and to get the ASDM to work, because you need it for certain things. I mean, you can do just about everything you want in the CLI for VPN, except for certain aspects of WebVPN. There's certain things you have to use. What is it? The bookmarks? I think it's bookmarks. You need the ASDM to do. You can't do that through the CLI. So it's been a long time since I've touched any of that type of stuff. But yeah, you can log in, but you need to be running an ancient version of Java, and it takes a minute for you to hack it down off the internet. You got to find it on some secure or some obscure website, download it, and then you can log into the ASDM on the ASA. So I was really hoping that they would, with the later and later versions of ASA, that they wouldn't do that anymore, where they would kind of flip it over to a web page like they do with the FTD, but they don't do that. So that is something I definitely want to go do, and I definitely plan on doing a workbook for VPN and all that type of stuff. But it's like I have a lot of things that I want to go create workbooks on. So high-speed crypto math comment. That's funny. Yes, I will be working on getting that out as soon as I can, because it's one of those things that's it's ever present. Like every day that goes by, I'm like like I said, if I could clone myself and put 10 of me in a corner and just have been pounding away at workbooks, that's what I would be doing. The videos have been great. I know somebody made a comment about that you get started and have to, or I can see the full courses and so yeah. So I plan on doing workbooks because that allows me to make sure everything's going to work. Put it into a workbook, release the workbook, and then do videos, or at least as close to it as I can in parallel, so that the videos are there. And so yeah, It's good stuff. Actually, now that you say that, one of the things that I really should do is deploy another Windows 10 or Windows 7 VM in my virtual environment, and then or my ESXi host, and then I mean it's one host, it's not an entire environment. Don't get me wrong. Deploy that so that I have it ready to go, and I can like peck away at it. It's like, oh, I feel interested in doing this today. Well, because who knew that I'd be sitting here at my house one day and I would just be like, something would give me the motivation to go mess around with remote access VPNs on ASA. I mean, yeah, I'm a nerd. At the end of the day, that's what I do. So anyway, that's it for that. So thanks for hanging out. I'm going to go ahead and let you guys go. I'm going to save this and put it out in the old Google Drives. I'll put the link in the description, and you guys should be able to see this here in a little while and all that good stuff that goes along with it. I fumbled with Proxmox and Eve. Well, I'm back. I don't blame you at all, man. I do know some people that use Proxmox and they have good luck with it, but it's just one of those things where I've always been an ESXi guy, so I'd rather I pay the $210 a year. I think it is for VMUG Advantage, just so that I can just keep ESXi because customers I work with use it, so it makes sense to keep. All right, gentlemen, because I doubt any ladies are watching at this point, but all right, gentlemen, I'm gonna let you guys go for the rest of the evening. You guys have a good rest of your night, and for those of you that have membership to the coaching sessions on Friday, I will see those of you that are interested in hanging out with me Friday evening. You can go ahead and do that. That's, by the way, in case anybody's curious. It's $10 a month if you want to have access to that. So anyway, you guys have a good rest of your night, and I'll catch you all in the next one.